Hello and welcome to another video. In this video we're actually going to be doing the daily because this is roughly the 2K problem that I've been doing. So I guess if the dailies are around there, I'll just do those. So in this one you're given a 0 index integer array nums and an integer modulo and an integer k. Your task is to find the count of subarrays that are interesting. Subarray is interesting if the following condition holds. Let count be the number of indices in the range L to R such that nums I mod modulo equals k, then count modulo equals k, return number denoting this. So kind of confusing what they're asking, but basically you can transform the numbers into is this condition true or not? It's basically like, is this number modulo mod equal to k? So essentially, like if we take example 1, we can just transform these numbers into like yes or no, or like ones or zeros. So like 3 mod 2 is k. So this is basically just odd or even. So we can transform it into this. And now we want subarrays where all of the sum of this thing, mod is equal to k. So basically the sum of this thing has to be odd. So what are some subarrays? Well, anything with just 1 1, so this or just the 1 itself. So this as well. So there's 3 there. Kind of confusing. Or actually, yeah, I think there's 3, right? Yeah, 0 0 0 1 0 2. Okay, so going to example 2. So we can do a transform again. So this is needs to be divisible by 3 basically. So this would just be like 1 0 1 1. And we need this total of the subarray to also be divisible by 3. So this is one of them. I think the other one is this. Yeah, 1 1. Yeah. So how do you find this out? It's kind of confusing, to be honest. And there are problems. There's like a subarray sum divisible by k or something, which we use prefix sum. So I was trying to do something like that, some kind of prefix sum. But I was trying to figure out like what do I actually need to make it equal to. And so we can figure it out from an equation, but I don't know how easy this is to come up with. I'm curious if some other people found some easier ways. But essentially, we can figure out like what we're trying to get, right? So if we have a prefix sum of, let's say we have a left and a right bound, like what's the formula we need to figure this out? So prefix sum is just going to be like the sum of this thing, which is going to include every number from 0 to this, right? Is it modulo by whatever it is, right? So if we transform these numbers to 1s and 0s, the sum up to this index minus the sum not including the left index, right? Because if I want the sum of like let's say I want the sum of this or like this chunk, how do I get that? Well, I get this whole thing minus the chunk before that. So that's where nums at the right index minus the nums to the index ahead of that. So that's just standard prefix sums. Okay. So this whole thing, like these numbers transformed, mod the modulo whatever needs to equal k. And so the way to do this problem in other problems is like we could have this pre-computed, and so we need to write this in a way where this thing is by itself, or basically you need to have this on an opposite side of this. So how do we do that? Because we have like everything else, and we can't really, so ideally we just want to have like that. We want to solve for like this, or this was something else. So what can we do here? Well, we can do a couple things. So what we can do is we can like move these around. So actually, by the way, this is like this. Yeah. So if we move it around, we can distribute the modulo because basically like a plus b mod equals a mod plus b mod. So this is like that. You can do that. So if we do that and we move this to the right and this to the left, what do we get? So we get sum r mod minus k equals sum left minus 1 mod. So we can have this calculated, right? Like we can just anytime we keep a sum, we can just store how many of these we have. But how do we know the next part? Like how do we know how many of these we have essentially? And so we need to have this basically like by itself completely, ideally. So how do we do that? Or actually, I think we need to maybe transform this somehow. Like we need to take this and we need to transform it into this. right? Like what value to look for. So yeah, I think we can just do this. This will be fine. So we can take like whatever the sum right is, we can mod it by mod. And then we can subtract k, and then we can get this. So I think this should actually be enough, and this would be fine. So like, for example, if our right total is like 5, we can mod it by whatever the modulo is. And then we can subtract k. And then we can check, like, okay, how many values do we have for this that are equal to that? And then for each one of those that you have equal to that, that's like a valid left index for your array. So basically, this is how you can calculate it. And then we can store these, right? So for every index we get to, we'll just store that index mod. And that'd be fine. Yeah. Okay, so let's actually try to copy this, and we'll use this for our equation to make this prefix something. If I can do that. Nope. Okay, well, we'll refer to it when we need to. Okay, so first, yeah, so essentially we're going to be storing the total, mod, and the total is just going to be total of all the numbers, mod is equal to k. Okay, so we'll say like prefix sums equals, so at, like the empty array is just going to be 1, so we'll just say it's like default dict, int. And so we'll say prefix sums. So the empty array will have a total of 0, and 0 mod, yeah, basically 0 mod will just be, and 0 mod anything is 0, right? So prefix sums 0 is 1. Have a result, and we have like a current running total. So for num and nums. So we just need to check, like, is this number mod equal to k? So we'll say total plus equals number mod equal to k. Okay, and so this is like this section, right? This sum right. Now we need to mod it by mod, and then we need to subtract k. So like our number we're looking for, we can call this like target, is total mod minus k. And so however many of these we have, that is a valid left side. So we can just say result plus equals prefix sums of total, or target. And we want to also increment this thing, right? So sums L minus 1 mod. So that's just going to be the current thing. So that's just going to be prefix sums of whatever thing we're at. So that's just total mod. I think this is right. Let's see if we get the right thing. Oops. Okay. Ooh. Okay, so we got a problem. We got 1. We expected 2. Well, let's see. So if we take this 225, this would be basically like 1, 1, and 0. And we need it. We need to include both 2's. So we have. So there's one array here and one array here. Okay. So maybe let's just print out the prefix sums at the end. So let's actually get like the total and the target. So let's go print total, target, and the prefix sums. And let's see if we did anything wrong. Okay, and let's add this to the test cases. Okay, so total is 1, target is -1. Yeah, so we don't have that. Okay. Then total is 2, target is 0. Is that correct? Total is 2, target is 0. Yeah, because it's the whole array. That's correct. Okay. Next, total is 3, and target is -2. That's not correct. Yeah, wait, why is the total 3 actually? Total can't be 3. Right? Yeah. Or actually, sorry. So 5 is actually true as well, right? 5 mod 3 is 2, so it's actually this. Okay, so total is 3. That is correct. And then what we're looking for is, so we don't have any -2. But like, what's a valid left index with this, essentially? Valid left index would be here. So we need this to be 1, and it's -1. or -2. Okay. So we're getting -2, but actually -2, like -2 is basically the same as 1. So we need to make sure to handle these negatives somehow. How do we do that? So where's our formula? Total mod minus k. I think we just can do like a, yeah. So we can basically just say like if target is less than 0, we'll just do like a reverse. I think that'll be fine. Okay, something like this. Okay. Oh, equals. Or wait, target equals k plus target. How's that? Okay. There we go. So yeah, so essentially like a negative is the same as a positive. Like -2 is the same as 1. So we can handle that. Interesting, we got another error. Okay, so let's transform this as well. So 2 mod 7. Okay, so this is a 1 now, this is a 0. So we're looking for, and we need to be only 1. So we got 1, we expected, actually no, we need to be, yeah, we need to be, let's see. We need to be, yeah, there's nothing that can happen here, right? Okay, so let's print this as well. So let's print total, target, and prefix sums. Let's see what we're doing wrong this time. All right. Oops. Okay, so total 0 is fine. Okay, total 1, target 1. Okay. So there's nothing there. Okay, and now total 1, target 1 again. Okay, so why is total 1, target 1 here? Like we have a total 1. Our target should be what? Let's see. Total mod, which is just 1, minus 2, -1. Yeah, -1. But we don't have it. I screwed this up a little. Yeah, I mean, we can also try avoiding negative numbers if that helps. I'm not sure. So we can avoid negative numbers here. We can just say like sum right. So we could distribute this mod thing. So the way to do that is we can do sum right minus k mod. But we have to make sure that if this becomes negative, we have to make it positive. So we can just ensure by doing this. And so we can do that as well, and then we can just calculate this instead. Will that be better? Let's find out. So we can get rid of this. So we can say it's a total mod. So we need total minus k plus mod. Like this. Then we don't have any negatives. Maybe that's why. Let's find out. We're still getting the wrong thing. Actually, yeah, because we don't need this k anymore. Okay, there we go. Yeah, so kind of confusing, kind of hard to come up with, I guess. But the main thing is like, you ideally don't want negative mod numbers, because I think negative mod numbers do weird stuff. So basically, what you want to sum up, I guess, is you want the left side to be by itself, like here. You don't ever want anything to be negative, because negative mods are going to be kind of annoying. And this kind of handles it this way, because basically we're saying like, if this is less than 0, we'll just add it to make it positive. And then, yeah, and then essentially, like, this is always positive, this is always positive, and this is how you do it. I do think this is kind of hard to come up with and a little bit mathy, but yeah, just basic, like, mod distribution should work. So, yeah, hopefully this is helpful. I know, kind of confusing, and then, yeah, I guess this is, like, a linear. And, yeah, honestly, the way I thought about this one was, yeah, just did the subarray whatever divisible by k thing, and that had prefix sums as well. So I was just like, how do I make this, like, what's the right target I'm looking for? That's kind of the main part of this problem. So the subarray divisible by k thing, you're trying to make it like 0. This, you're trying to make it this, but it's literally the same exact stuff. So yeah, hopefully this is helpful. Let me know if you have any questions, and I'll see you next one. Thanks for watching.